Hello, Coach Holmes here, and today we're going to be talking about Pythagorean Theorem. And this new unit we're talking about is basically dealing with right triangles. And there's a lot of unique things with right triangles that we can use and be able to work problems out. But for the first thing we got to do is we got to get a good understanding of Pythagorean Theorem. So first off, what is Pythagorean Theorem? Well, if you remember in junior high, a squared plus b squared equals c squared. Okay? Now, that seems like a pretty simple problem, a simple equation, but what does the a, b, and c mean? Well, both a and b are your legs. Okay? They're the leg of the triangle. So, for example, this shorter length right here, that's a. Basically, any length that makes the right angle. So that's one of them, and here's the second one. Now, I could easily say this will be B and this will be A. I can easily say that. Okay, it doesn't matter which one's which, just as long as we be able to use both of them as the right angles. Okay. Now, C right here is what we call the hypotenuse. Okay? C is the longer length. It's basically the length that opposites the right angle. And typically the hypotenuse is always going to be the longer length. Okay? That's typically what it's going to be. It's going to give you the longer length. So, if I look at some of these problems here, look at some of these examples. So notice that I have a leg and another leg. That leaves me with the hypotenuse missing. I gotta find what x is. So in order to solve it, I gotta do 5 squared plus 12 squared equals x squared. Well, I know that 5 squared is 25 plus 12 squared is 144 equals x squared. Next, I add them up together to get me 169 equals x squared. Now, we'll talk more about this tomorrow, but what we call this square root is basically we'll call it radical, and we'll talk about radicals more later on. But if I take the square root of it, that cancels out the square, and basically I got to think of a number times itself to give me 169. So if I check on my calculator, which in the calculator you just go second squared plus 169, and it gives me 13. So x is going to give me 13. Now, let's try this next one. Well, I'm missing a leg, but I have one leg and the hypotenuse. So really, now again, doesn't matter which one I plug in for, doesn't matter which one's, whether it's A or B, doesn't matter which one's 7? No, not really. Just as long as I'll be able to figure out, just as long as I know, one of them has to be X, the other one has to be 7. So I'm going to say x squared plus 7 squared equals 14 squared. Now, I personally know 7 squared is 49. 14 squared is 196. So I'm going to subtract 49 from both sides. So subtract 49, that gives me 147 equals 7 squared. I don't like that 7. So now again, in order to solve this, I gotta take the square root of it. Let me go this way. So x is equal to, just give me 1 minute. 12.1243, but I'm going to do 2 decimal places. just to keep this nice and simple. Okay? And that's basically rounding down because 4, you don't round up with a 4. Right? But that's how I go about solving for Pythagorean theorem. Now, there is something interesting called Pythagorean triple. Okay? These are very, they don't happen that often, but they're very neat. These are basically values of lengths of from the right angle. Let me say it that way. Length from the right triangle, I mean, with no decimals nor fractions. Okay? So basically, these values, there's 3 lengths where they're actually whole numbers that makes a right angle, or makes a right triangle. And here's some of the examples. 3, 4, 5, 5, 12, 13. And let me check one more because I can't think of it at the top of my head. But I have it. I know what to look for. 8, 15, 17. Okay? So basically, and there's plenty of more, and there's more we can come up with, but these 3 right here are good examples of Pythagorean triple, where if I square these, like if I use this for example, 3 squared plus 4 squared equals 5 squared. Basically, if I work it out, they're going to equal to each other. So 3 squared is 9 plus 16 equals 25. 9 plus 16 is 25. Equals 25. So 3, 4, and 5 are lengths of a right triangle. Okay? And so is 5 and 12, 5, 12, 13, and 8, 15, 17. They all work out. Next, we're going to talk about Pythagorean inequalities. We're going to talk about the inequalities of Pythagorean theorem. And basically, the 2 inequalities we have is pretty much greater than or less than. And what they tell us is that if c squared is greater than a squared plus b squared, that's an obtuse triangle. No matter what, that's always going to be the case. C squared less than a squared plus b squared is acute, no matter what as well. So, what we got to be able to do is determine which one is which, as far as which one is obtuse, which one is acute. Well, here's the key to remember. C is always the longest length. Okay? Whatever the longest length is, whatever the biggest number is, it has to be C. Okay? So let's look at these examples real quick. So I got 10, 11, and 14. Okay? Well, I know 14 is my biggest length. So I'm going to say 14 squared, and then I'm going to say 10 squared plus 11 squared. And then I'll figure out which one's going to be bigger or greater, which one is bigger than or less than. Well, 14 squared is 196, because we just talked about that earlier. 10 squared is 100. 11 squared is 121. Add them together. 221. Well, I know 221 is bigger, so that means that it's right down here. I'm going to put it right here. Now, that means that the a squared plus b squared is greater than, which means in this case, it has to be acute. Okay? Now, let's look at the next one. Now, I do, like I said, determine which one's the biggest. Well, 10 is bigger. So 10 squared, 6 squared, plus 8 squared. 10 squared is 100. 36 plus, what was it, 64? Wait. Yeah, 64. So then I add them up. That gives me 100. Let me make sure, because I feel like it's, yeah, it works out. Okay, so they're both equal to each other. Well, what does that mean if they're equal to each other? It's just a right triangle. And so basically, we actually got another Pythagorean triple. That's a Pythagorean triple right there. Kind of interesting. Okay, so there's more than, so like I said, there's more than these three. And just thinking about it, I know why it would work, but different story. Anyways, so we do have a Pythagorean triple here, and is it if they just happen to be equal to each other, they're just a right triangle, just like regular Pythagorean theorem. Now let's try this one. So my biggest number is 12.2, so I'm going to do 12.2 squared, and then 4.1 squared plus 8.2 squared. 12.2 squared is 148.84. 4.1 squared plus, let me do that, 16.81 plus 8.2 squared is 67.24. I add those together, that gives me 84.05. So I mean, just by looking at it, I know this has to be greater. So if this is greater than right here, then that means I have a obtuse triangle. So the biggest thing that we gotta keep in mind is that Pythagorean triples, they have no decimals, no fractions. And when it comes to inequality, if the c squared is greater than, it's obtuse. If c squared is less than, it's acute. And just like what we worked out earlier. If c squared is equal to a squared plus b squared, it's just simply a right triangle. Something we've been working out before. All right, thank you and have a good day.